Hi, my name is Andrew from IlluminesceSense. I'm joined today by two of my partners, Noel and Christina, and we will be talking about our LED dance floor project that we've been working on for this semester. As its name suggests, the LED dance floor is meant to be a dance floor with a little bit of a twist. By adding a lighting element directly into the floor, we now create a brand new type of environment within the establishment that is implementing our technology. The motivation behind this particular project is to allow nightclubs, bars, and other similar establishments to be able to offer something different to their patrons that they wouldn't otherwise experience. The interactivity of the environment would give patrons a feeling of being in control of their experience and become a talking point when they mention the establishment to their friends. It would also add to the establishment's differentiation from competitors and encourage repeat business. The way that we are able to generate this unique experience is through several different types of methods. Noel is later going to discuss the structure of the panels in detail, the frame that it's housed in, the LEDs, and the pressure sensors that will be underneath that and will react to people's weight as they traverse the dance floor. Christina will be speaking about the near-field communication system that we will be also implementing and the function of the microcontrollers as well. The combination of these two inputs, as well as the potential of adding elements of sound reactivity, will also contribute to which lighting effects patrons will experience in the club. The system is customizable, and we do envision variations of the concept, such as removing the sensors for large outdoor displays, or increasing the sensitivity to illuminate bar tops or tabletops and things of that nature. Additionally, we feel that similar technology can eventually be used in areas such as home security or road safety, or something as simple as helping elderly people move about their homes with lights that will essentially turn themselves on or off when they're needed or not needed. In the nightclub industry, entertainment lighting is extremely important. We previously had the opportunity to speak with the general manager of the M nightclub in downtown Honolulu about the financial feasibility of our system at his club. He mentioned that in his club they've spent several hundreds of thousands of dollars on their lighting system alone, and that just shows how important it is to establishments in the industry. Our construction cost, as you see, is a little over $200 per square foot, but hopefully we're going to be able to bring that number down as we mass produce the panels. Now I'll go ahead and hand it over to Noel so he can discuss the details of the structure and pressure sensitivity.
In the last 8 months, we worked on multiple lighting prototypes. The design choices can be separated into two groups, direct and indirect lighting, each having their own advantages and disadvantages. Direct lighting faces the light source perpendicular to the floor surface. In order to achieve optimal lighting saturation, we built an elevated pixel box. The fabrication of these boxes became very time-consuming, so we decided to implement a flat design. However, this improvement sacrificed light saturation as seen in the upper right image. The next design choice we experimented with was indirect lighting. This faces the light source parallel to the floor surface. In order for the light to bend perpendicular, we needed a fogged material. Our first experiment with fogged acrylic failed to embed the light farther than 2 inches. Too much light was bending too early in the material, so we moved to a buffed clear acrylic. This new design allows the light to bend 6 inches on either side of the material, optimal for our 12 by 12 inch design. Next, we would need a stable way to hold the LEDs, acrylic, and sensor electronics. This design that we call the frame is a plastic material with a dimension of 12 by 12 by 1.5 inches. The base frame is lowered by 1/2 inch and is routed by another 1/2 inch to embed the sensors and electronics. The outer 1/2 inch holds the acrylic base, and the spacing between the lip and the acrylic holds the indirect lighting source, or LEDs. After everything was cut, we assembled the base frame with the outer lips using wood screws. The acrylic was buffed using an orbital sander with a grit of 100. The bottom right image is the final product design. The frame will embed 2 sensors. This force-sensitive resistor allows the LEDs to react based on the pressure applied to the acrylic surface. As force is applied to the sensor, a layer of semiconductor material lowers the pressure applied from a range of 100k ohms to 200 ohms. This pressure is measured by a change in voltage through a voltage divider circuit. Our design embeds 4 FSRs on each corner of the pixel, allowing for a dynamic range of interactivity.
NFC stands for Near Field Communication. It operates at a frequency of 13.56 MHz. Its applications include keyless entry and payment systems. The purpose of using NFC in our project is to add personalization with tags. Using Maxwell's equations, specifically Ampere's law, we can see that the induced current in the loops of the patch antenna creates a magnetic field that allows our transceiver to read passive tags operating at the same frequency. The NFC controller, as well as the antenna, were designed and optimized using EagleCAD and milled in Dr. Garmeyer's lab. Both sensors and LED strips will be read and driven by ATmega 328 microcontroller. The code is written in C, and just like the NFC antenna, we designed a custom PCB to accommodate the chip. Reacting to these sensors will be Adafruit's NeoPixel LED strips. These low-power diodes emit a 0 to 255 red, green, and blue light intensity, allowing for any combination of hexadecimal color scheme. Each LED is individually adjustable, which gives a variety of patterns that will associate with the various sensor values. By utilizing different types of technologies ranging from NFC to varying LED arrays, we plan to create interactive entertainment with mobile dance floor tiles. The applications of this technology are numerous and can be applied to lighting homes to improve safety and power saving, particularly of the elderly. To prove the success of our project won the Manoa Breakthrough Innovation Challenge this semester for its creative and novel application. We learned the design process of printed circuit boards, PCB milling method, prototyping development, and marketing products.